Hello students, in this video lecture I am going to cover another important topic of memory management, that is page replacement algorithm, hardware and software control structure, operating system software. So let us discuss one by one. So firstly, page replacement. As I have discussed in the previous video, whenever a process is executing, this may be possible the entire process is bring up into the main memory. So some part of the program may reside in the secondary memory because a number of processes may be residing in the primary memory. So when a page fault occurs, means CPU, the address generated by the CPU is not found in the main memory. So it is the responsibility of the operating system to bring up that page from secondary memory to primary memory. So the CPU or operating system will stop the execution and hand over the control meanwhile to the another process and bring up the page into the main memory. Before bringing the page into the main memory from the secondary memory, it has to find whether there is any empty slot or not. That means empty frame or not. If it is, then there is no problem. Otherwise, it has to swap out any one of the pages and then after bring up that pages from the secondary memory to the primary memory. So how will it take place? We will discuss in the next 4 to 5 slide the process of page replacement. We evaluate the algorithm by running on a particular sharing or string of the memory reference. So there is a memory reference string that basically count the pages, which are the pages required by the CPU. The string of the memory reference is called reference string. For a given page size, we need we need to consider only the page number rather than the entire address. Second, if we have the reference of the page P, then any reference to page P that immediately follow will never cause the page fault. The page P in the memory after the first reference, so immediately the following reference will not fault. So let us consider the basically pages that are required by the CPU. So we have to find out the reference string from this, get the memory reference string, and then after there are three techniques. First one is the uh, FIFO, second one is the optimal, and third and last one is the LRU, page replacement algorithm. So we will discuss one by one. So this is the page basically address generated by the CPU, and from this we can find out the reference string. Here the reference string is 1 from this one, then after this is the address 4, then after again this is 1, then 6, then 1, then 1 is continue 1 1 1 1, then there will be 6, so we will take 6, then after 1 1 1 1 1, so we will take all 1, then 6, then again 1, and then after this is a 6, so we will consider 6, then 1 and 1 1. So by this we can find out the reference string as follows. Once the reference string is generated, now how the page replacement will take place? Let us search the entire vacant frame. If it is not, we have to replace the page. So with this, the page replacement can be done with the help of the three algorithms in our curriculum. So firstly, find the location of the desired page on the disk, locate a free frame. If there is no free frame, use the page replacement algorithm to select the victim pages, write the victim pages back to the disk and update the page and frame tables accordingly. Read the desired page into the free frame, update the page and the frame tables, put the process back into the ready queue to get execute. So these are the steps. Basically, these steps we have discussed in the page fault process. So this is how we can find out the whether the page is valid or invalid. If page is invalid, that means the page is not in the memory. So we have to bring up swap in that page from secondary memory to the primary memory. So now, what is the criteria for page replacement algorithm? It should be efficient and cost effective, because if the it is not efficient, in that case what will happen, it may cause the wastage of the cpu utilization. And cost effective means it should not bring up the entire file, so that when a new process comes and it is going want to get execute, it cannot get executed. So in the multi-programming system, the number of processes can execute simultaneously. So there is a need of the swap in and swap out of the pages. So swap in and swap out of the pages should have the least cost. So let us discuss all the algorithm. Firstly, FIFO. It is the simplest page replacement algorithm. FIFO page replacement algorithm chooses the oldest page in the memory. Implementation requires FIFO queue, holds identifier all the pages in the memory. We replace the pages at the head of the queue. When the pages is brought into the memory, inserted at the tail of the queue. This is the process how the page replacement will take place. So here is the replacement, basically the reference string. Initially, the entire page table is empty. So whenever there is a need of the 7, so it will be placed in the memory. Then after 0, so still page is frame is free, so it will be inserted here. Then there is a address that is 1, so it will be bring up into the main memory and inserted. Now, whenever there is a address generated by the CPU is for the page number 2. So 2 is not in the main memory, so it has to replace one of the page from primary memory to the secondary memory. So it will search for the victim pages. As the algorithm is FIFO, so first this page was in the memory, so it will replace this page and bring up the page number 2 into the primary memory. Now the situation will be 2, 0 and 1. Now 0 will referenced by the CPU, 0 is already in the memory, so there is no issue. Then after it will generate the reference 3. Now it will search for the 3 is present in the page table, no. So page fault will occur. Now 2 is just arrived, before that 1 was arrived. Now the oldest page was the 0, so 0 will get replaced by the 3. So here now the situation will be 2, 3 and 1. Now CPU will generate again that is 0. Since 0 is not found in the memory, so it will search for the oldest page, that is 1, so it will get replaced. So 1 will be replaced by the 0. Now the 4 address is generated as a reference. Since the 4 is not in the memory, the memory page table contain 2, 3 and 0. So the oldest page is the 2, so it will replace 4. It will bring up 4 by replacing 2 and then 3 and 0. So this process will continue how the page replacement in the FIFO will take place. If page is not there in the main memory, that is known as the page fault. So here there is a page fault because 7 was not in the main memory, 0 was also not in the memory, 1 was not in the main memory. So there are 3 page fault. When 2 is called, 2 was also not in the main memory, so this is another page fault. But 0 is already in the memory, that is referenced by the CPU, so here it is not a page fault. So whenever a page is found in the main memory, so that is not treated as a page fault. Whenever the page is not found in the main memory and it has to get replaced from the secondary unit to the primary unit, that means primary memory. So that is known as the page fault. Now, optimal. In the optimal algorithm, it is better than the FIFO. How will it work? Let us see. It will search for the reference string 7. Here is a page fault. Then after 0, it will bring up into memory because there is sufficient space, or we can say the frame is empty. So 0 will be bring up. Then after 1, yes. Now it has to replace the page. Which page should get replaced? So here the optimal page, it will search which is not used. So it will search for the next page that will not is going to need in the near future. So here the page number of 7, 0 and 1. So we will search. 0 will be used here, 1 will be used here, and 7 will be used as will be demanded at the last. So it will replace the 7 first. So it has replaced the 7, then after 0 and then 1. Then 0 is referenced by the CPU, it is in the memory, so there is no page fault. Now there is a address generated by the CPU as a 3. So 3 is not in the memory. So which will be get replaced? 2, 0 and 1. So 0 is required here, 2 is required here. So 1 should be the victim page because 1 is replaced, 1 required is here. So it will replace 1, 1 by 3. So 3 will bring up into the main memory. Now 0 is required, 0 is already there. Then 4 is required. Now 4 is not in the main memory. 0, 2, 0 and 3 are there. Then which will be replaced? So it will search 2, 0 and 3. So 2 is required here, 3 is required here. So 0. So 0 will be treated as the victim page and it will be replaced. So this is the process in the optimal. It will search the entire string firstly, which is the page required least in that, or we can say not least, in the later. So it will replace that page from the page table to the secondary memory. Although it is optimal because it requires lesser number of page page replacement, but it has to scan the entire string with again and again before replacing the pages. So this is an overhead. Now LRU. LRU stand for the least recently used. It will replace the page that is not used from a longer time. So it will replace that page. Here 7, there is a memory space when CPU generate the address reference 7. So memory space is frame is free there, so it will be inserted. Then after 0, 0 free frame, so 0 will be bring up into the main memory. It is also treated as a page fault. Then 1 is not in the main memory but it can be bring up into the main memory in the free frame from the secondary memory. So there are 3 page fault. Now there is a there is a address 2 that is generated. Now which one was not used since a longer time? One is just used, 0 before that, 7 was not used for from a longer time. So it will be replaced 7 2 7 by 2. So here 2 will be bring up into the main memory. Now 0 0 is just 0 is now used because it is in the main memory. Then after 1 will be there, then there is a need of the 3. So 0 is just recently used, before that 2 was bring up into the main memory. So 1 was the victim pages, or 1 is the victim pages that has not used from a longer time. So here 3 or 1 will be replaced by the 3. So 3 will be bring up into the main memory. So 0 is 3 is just used, 0 is just before that, and The least recently used was the 2. So now there is a demand of the 0. So 0 is now just used, and then after, and here is no page fault because 0 was already in the memory. Now there is a need of the 4. So 0 was just used, before that 3 was used, and 4 was the least recently used. So 2 will be replaced by 4. So this is the process in the LRU how the page will get replaced. Belady anomaly. Belady anomaly basically a problem in the FIFO page replacement algorithm. According to that, if we are increasing the number of frames, definitely the page fault should get decreases. While a special case of the FIFO algorithm, if we are increasing the number of frames, the page fault also get increases. So this was seen by first time by Professor Anomaly. So on the name of that, it is known as the Belady anomaly. So here, if number of frame is 1, so page fault was 12. If number of frame was 2, the page fault was still 12. If we have increased the page number of frame as 3, so page fault decreases to 9. Now we have increased the number of frame as 4, so page fault get increases. So here there is a abnormal situation. This normal abnormal situation is treated as the Belady anomaly. Now, global and local rate page replacement means, suppose that I am using a word editor. This is the operating system, and I am using a word file w1. As I have discussed already, when we are using the word file, it is divided into the sum of the part. First one is known as the data part, and second one is known as the editor part. There is another program that is of the word file is bring up into the main memory. So its data part will be bring up only in the memory, that is a D2, not the editor. Not the editor, because our editor is already present in the main memory. Why we should bring up the another copy? Because if operating system will bring up the same copy once again, there is a redundancy of the copy, multiple copy, and it will occupy the space in the main memory. So automatically it will reduce the chance of the another process to bring up in the main memory, because it will occupy some space. So in case of local replacement, when a process is swapping out from primary to the secondary memory, it will replace the entire part, data as well as editor part. Still, if the part of editor is using by the process, another process p2, but it will replace the entire part, data as well as editor part. While in case of local replacement, it will replace only the data part of the process 1, while editor will remain continue because it is used by the another process p2. So in the global replacement, entire process will get replaced, while in case of local replacement, only the part that is not associated with any another process will get replaced from primary memory to the secondary memory. Thrashing. As we know that if we are increasing the number of programs in the main memory, the utilization of the CPU increases continuously. But there comes a stage when we are increasing the number of multi-programming. There comes a stage after that the CPU performance get decreases. How? Because in that case, all program will have only one page of each process in the main memory. When CPU want to execute two pages, next pages, the next pages will not find in the main memory, so automatically page fault will be there. Whenever there is a page fault, CPU will take A context switch means it will switch over from one process to the another process. In that case, it has to save the PCB of currently executing process into the main memory. Then after, it has to replace one of the process page that is already in the memory to the secondary memory. After the frame get free, it will bring up in a page from secondary memory to the primary memory that for that process, and then after get restarted. So this is the burden of processor. While context switching is taking place, the CPU will not perform any work because it will sit idle. So automatically the performance of the processor or the system will get decreased. Here it is the example. So as we are increasing the degree of multi-programming, the utilization is increasing continuously. And after a certain time of interval, when the number of multi-programming reaches at its limit, automatically there is a sudden decrement in the performance of the CPU or CPU utilization due to the page fault. So this is known as the thrashing. This activity is known as the thrashing. Now, pre-paging. Pre-paging is an attempt to prevent this high level of initial paging. The strategy is to bring into the memory one time all the pages that are needed. Means whenever the pages are a process is bring up into the main memory, the entire process pages is bring up into the main memory before it get start execution. So this is known as the pre-paging. So all associated pages will be already in the main memory before get before that process will get started to execute. So this is known as the pre-paging. Now in the curriculum there are some portion that let me discuss once again. There is a hardware and control structure. Hardware and control structure covers the locality and virtual memory that we have covered up, paging, we have covered up, segmentation, we have covered up, protection and sharing. This we have already covered up, not in this video, before that. And second one is known as the operating system software. Operating system software basically covers up the locality. Locality means temporal, and spatial locality means we have to bring up the entire programs in the main memory, or whatever the pages that are needed to reference in the near future, that will be bring up into the main memory. This we have discussed in the unit number 1 in detail. Second one is the virtual memory. This we have discussed. Then policy means demand paging and pre-paging. How to fetch the pages from the secondary memory to the primary memory. Page replacement algorithm, best fit, worst fit, and best fit we have discussed. Then replacement policy, LRU, FIFO, and optimal. This we have discussed. Resident set memory means global replacement and or local replacement. Then cleaning policy, how to replace the pages from primary to secondary memory, how to find out the victim pages. So a cleaning policy is opposite to the fetch policy. It is concerned with the determining when to modify the page should be written out of the secondary memory to the out to secondary memory when we have to replace the page from primary memory to secondary memory. Load control, thrashing means process suspension. If the CPU utilization is decreasing continuously, so we have to control the load, means we have to uh, swap out some of the pages that are executing at present to increase the CPU utilization, and so on. So these are the some of the part that we have already covered in the previous lectures, comes under the section operating system software. So this is from my side. Thank you.